Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 36, and this is lecture number 14 of the Physical Chemistry chapter Liquid State. The subtopic of this lecture is Effect of Temperature on Surface Tension. Let's begin with the idea of molar surface energy. If m is the molar mass of a liquid and d is its density, then m by d must be its molar volume. And if this molar volume is cubic in nature, then its side length must be cubic root of m by d, and the area of any side of that cube must be its square. So m by d to the power 2/3 is equal to molar surface area. Now we know that surface energy is the product of surface tension and surface area. So if we put molar surface area in place of surface area, then surface energy becomes molar surface energy. So molar surface energy must have the expression surface tension into molar surface area. Now we know the value of these two parameters. Surface tension, it has been taken as gamma as shown here, and molar surface energy, surface area, just we have found its expression m by d to the power 2/3. So the expression of molar surface energy must be equal to gamma into m by d to the power 2/3. Now the dependence of surface tension as a function of temperature by means of the Eotvos equation. He had suggested that molar surface energy of a liquid linearly decreases with temperature, and the linear equation is actually y equal to mx plus c type of equation of a straight line, which would have a negative slope like that. So this is the y parameter, it is plotted in the y-axis. Temperature T is the x parameter, which is plotted in the x-axis. So a straight line is obtained with a negative slope, and the slope is minus k, while z is the intercept. So these two are constant, and they would depend upon the nature of the liquid. If this equation number 20, it is carried forward in the next slide, and according to this equation number 20, if the temperature is increased, then the temperature of a liquid may increase up to its critical temperature where there will be no surface tension. So in that case, if T is replaced by critical temperature Tc, then in that case gamma becomes 0, that is surface tension becomes 0. As a result, surface energy would also become 0. So this way mathematically we can find the value of constant intercept z. So if T increases up to the critical temperature Tc, then surface tension becomes 0. Thus equation 20 takes the form. What should be the form? Just put Tc in place of T and put 0 in the left hand side like this. So 0 in the left hand side minus k Tc plus z. So what is the value of z? It is nothing but k Tc. So let us put this value in equation number 20. So here we should put k into Tc. In this equation, look, this is the value. Look, this animation here, the straight line, it is increasing up to here, it is being extrapolated up to here. This is the point Tc. Look at this. So this is the point Tc. Okay, and what about z? If you extrapolate this line up to this y-axis like this, like this, then this point is ktc, that is, this is the value of z. So z is ktc, and this point is presenting Tc, that is the critical temperature, where the surface tension as well as molar surface energy is 0. So let us put this value in equation number 20, and we get the form molar surface energy equals to minus kt plus, in place of z we are writing here ktc. So the final form of the equation is this one, equation number 21, and this is the Eotvos equation. So this equation represents the temperature dependence of surface tension, but this is a theoretical equation. When practical experiments are done, then Ramsay-Shield later found that this point is being cut before 6 degrees of the critical temperature in the x-axis. So it is found on extrapolating the graphical plot of surface energy against temperature it meets the temperature axis at Tc with a negative slope k according to the Eotvos equation. But later Ramsay-Shield experimentally established that the line cuts the temperature axis approximately 6 degrees before the critical temperature. That is, it is cutting the point at Tc minus 6, not at Tc. So the equation must be modified. In place of Tc, this is equation number 21. So in place of Tc, we have to put Tc minus 6 like this, and thus we get equation number 22, and this is the final form of that equation. And this is the Ramsay and Shield equation. So how does it look graphically? We carry forward this equation number 22 in the next slide, and graphically it looks like this. So according to Eotvos, the equation should be like that. That is, surface tension or as well as surface energy becomes 0 at this point, and this point is nothing but temperature Tc. But experimentally it was found that the point should be here, and this point is Tc minus 6. That is, from this to this there are 6 degrees Celsius distance between this point to this point. So at T equals to Tc minus 6, experimentally at that point surface tension as well as molar surface energy becomes 0 of any liquid. The value of the slope k, it is 2.1 for the liquids which are non-associated, and this is a constant definitely, and for the liquids which are associated liquids, that means water, ethanol, acetic acid, in that case it is not a constant, and the value is 2.5, but it rises with temperature. So that's all about dependence of surface tension on temperature. So thank you, have a nice day.